Hi folks, welcome to week 3. This is hydrocarbon chemistry, and what I'm going to do is I'm going to make a couple of videos for this morning. Basically what you need to be able to do is to be able to draw and name hydrocarbons in this section. Hydrocarbons are one of the biggest areas of chemistry. We're talking about everything here from wood products to gas and oil to plastics to pharmaceuticals. It's a huge area. So what we're going to be looking at is anything made up of carbon and hydrogen. So what I want you to understand first of all is every time that you see a carbon, it's going to have 4 lines coming away from it. 1, 2, 3, 4. 4 lines or bonds. So if you are in the middle of a carbon chain, you'll have 2 hydrogens. If you're on either end, you'll have 3. So this is a structural diagram. This is called a condensed structural diagram, where we write down the carbon, the number of hydrogens, carbon, number of hydrogens, carbon's number of hydrogens. Now, this here is called a skeletal diagram, and this is my preferred diagram. So the way this works, this and this are the same thing. In chemistry, we often leave the hydrogens off. And what we do is we draw a dot for a carbon, and every time we switch directions, there's a dot. So there's a carbon at the beginning, in the middle, and at the end. So another way you'll see this drawn is people will just leave the hydrogens off, and they'll just put little ticks like this. So it'll go 1, 2, 3, 4, 5. Okay, so you just switch directions every time. And the reason they do the switch of directions is the carbons don't line up in a straight line. Every one of these angles here is 109.5 degrees. And that's explained in grade 12 as to why that occurs. You can have different lengths of carbon chains. For example, 1 carbon is methane. 2 carbons are ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Now you might notice that a lot of these things are fuels. So methane is natural gas, propane's popular in barbecuing, butane is in lighters, octane is used in gasoline. So it's the main component or the high quality component of gasoline. So what you have to understand, first of all, you've got to have this list written down and beside you when we're doing things. Now, the other thing that can happen is you can have single bonds, double bonds, and triple bonds. So we've got a single bonded carbon, we've got a double bonded carbon, single, single, single. Okay, first thing, here's your hydrogens going in. If you have a double bond, the carbons only have 1 hydrogen because each carbon needs 1, 2, 3, 4. Needs 4 bonds. So it looks like this. How do we name this? 1, 2, 3, 4, 5, 6. We go to our list. 6 is hex. So we write down hex. If we have a double bond in there, it's now changed from hexane to hexene. And now what we do is we've got to get the location of that double bond. 1, 2, 3, 4, 5, 6. The double bond starts on the second carbon. So the number is a location. It's 2-hexene. What about this one? 1, 2, 3, 4, 5, 6. You might be tempted to say it's on the 4. But you always start from the end of the carbon chain that gives you the lowest numbering. So this is also 2-hexene. 1, 2, 3, 4, 5, 6. Hey, I want to keep reminding people, you can go over a video again and again and again. You can stop it. Make sure that you take a look at things. Let's do one that's more complicated. 1, 2, 3, 4, 5, 6, 7, 8. That's oct. We have 2 double bonds. 1 on the second carbon and 1 on the fourth carbon. In chemistry, the numbers, in organic chemistry, the numbers are locations. There's 1 on the second, 1 on the fourth. Commas go between numbers. This is going to be very important. Commas go between numbers. Dashes go between numbers and names, or names and numbers. If you have a number and you have a name, you must have a dash there. So this is now octadiene. So this is how many double bonds you have. This is the location of the double bonds. Just another way you see this written. Sometimes the di goes out front. So it can go right before the ene, or it can go out front. Okay, don't get too caught up on the mechanics of, oh, that sounds awkward. If you don't quite write it properly, so if you just wrote octadiene, I would still give you the marks. As long as you have the proper numbers with the commas, with the dashes, and with the prefix, the di, you will get the marks. Okay, folks, I just wanted to introduce you to a couple of things right now. I wanted to introduce you to a couple of forms of drawings or namings, what the numbers mean, what the roots mean, how we do double and triple bonds. Actually, you know what? I think I'm going to draw this 2,4-octadiene. Here's something interesting. Every time you get to a double bond, it straightens out the chain. So that's 1, 2, 3, 4. Straightens out the chain, and then we keep going. If your drawing looks awkward, I'm not going to take marks off when you do this, okay? As long as you're getting the right number of carbons, double bonds in the right place, as long as you do those things, you're going to get the marks as you do this. I think that's good for part 1. That's enough to digest. I'm going to do part 2. So what I'm going to start doing now is adding things onto the carbon chains. So these are our starting points in organic chemistry, and then what we do is we change those chains to make new things, and we'll do that in the next video.